To start, we're going to review downloading the programs R and RStudio to help with running R. Now, if we open up our syllabus, the links for the R software and RStudio are available on the syllabus. Now, when you're downloading these, you need to download R first and then download RStudio. In fact, if you go to this site, and it goes here, it tells you, if you try to download RStudio first, which is in POSIT, it tells you to install R first and then install RStudio. So if we go to the C-Crane project, we can download that, and we can download it for Linux, Mac OS, or Windows, depending on what you have. And then if you click on that, it can have you install for the first time. And you can follow the instructions for downloading R here. Once you've downloaded R, you can then download RStudio Desktop for Windows. If you scroll down a little bit, you'll get it for Windows, Mac OS, and then some Linux systems. So you'll need to download R. But remember, first download R and then download RStudio. Once you have that downloaded, you should be able to open up R, which if we open up R, you'll get something that looks kind of like this. And this is the first ever R command file, and we can, in our console, we can do a couple things. We can have 2 plus 5, we get 7, we can have 3 divided by 9, and we get a third, and we can do things like this. But this isn't really the power of R. The console is where everything is run and computed, but the issue with typing in the console is that once it's typed, yes, you can press the up arrow and down arrow to see what you've done before, and we can start seeing some of the things that I've done before. But you can't see what you've done before, and you can't rerun commands that you've done before. So what we do is we'll create what is called an R script. Now, an R script is a place where we can write different commands we'd like to write. Let's say 3 plus 5. Let's say we wanted to do 3 plus 5, and then we wanted to do 6 divided by 4. Well, here we could write 3 times 5 and 6 divided by 4, and if we press enter, nothing happens. It just keeps creating new lines. But if I go here and I press shift and then press enter, nothing happens. If I press control and then enter, oh, when I press control and enter, all of a sudden it ran. And now if I go to this and press control enter, now it ran that piece. Now what happens if I press control shift enter? Well, if I can press control shift enter, it will run the entire script, everything that's there. Now, this is great and everything, but we've now just written numbers. But what if we want to use those numbers? Well, we need to store them somewhere. And what's happening when we type out something like 3 plus 5 is the 3 plus 5 is created, it's expressed down here, and then it's forgotten. But if I want to store it somewhere, I need to tell it, put it somewhere. And this arrow dash tells me whatever's after it gets put in the thing before it. So if I have number arrow 3, I can now see over here in my environment. My environment is what stores data. My environment, I have number, and it's 8. So whatever was computed here. And now I can, let's say I have ratio, and I want to store this ratio. I still have to run it in order for it to take place. Now I store it. Now, let's say I want to save this script. So I've made a script that does stuff. I want to save it because I want to be able to send somebody else what I've done, or I want to be able to download it, what we can do is File, Save As, and I'm going to save it in my math folder under tutorials as homework1.script. Save. I'm going to replace this. So now I have saved what I have here. So if I were to close it, I could then reopen this homework1.script, and I reopened this file. Which is pretty nice. Now, this is great that we can type numbers in here, but if we go back to that file folder before, we have this data1.csv, which is the different colored marbles that we had stored in the bag from course notes. What I'd like to do is I'd like to somehow get this data on into R. So I'd like to pull that data into R, and then I'd like to do stuff. So the first thing that I'm going to do is I'm going to show you how to pull data, copy data from a CSV file. And the first thing that we're going to do is we are going to actually set our working directory. And we want to set the working directory to where our data is. It doesn't have to be where your script is saved. It's where your data is. But if you recall, our data and our script are saved in the same location. So I can just press Session, Set Working Directory to Source File Location. And then it does what it needs to do to set the working directory. But now it's where the data is stored, which means I can now upload the data into a data frame. And a data frame is the name for an area where data is stored. Okay, and the way that we want to do that is we want to read what is called a comma separated file. And what a comma separated file is that this data is stored and it's separated using commas. So to get this data back, I want to store it somewhere. So I'm going to store it as my data. I'm going to store it into a thing called data, and I'm going to get it by reading the CSV file. And when I read the CSV file, I have to tell it a few things. And if we look here, it's telling me what I have to tell it. So I don't have to give it everything, but there's a few things that I do want to give it. First thing, I want to give it the file name. So to give it the file name, I'm going to type file equals, and then I'm going to give quotes, and it's going to be data1.csv. Because what I'm going to do is I'm going to give it the exact name that it has here, so it knows where to grab from, including the .csv. Then, if we look at this data, and we go to data 1, there is something called a header. And the header here is the labels for the types of data. And sometimes data in the CSV won't have this header. And other times it will. So it's important to know whether or not the header is there. Now here, because it has those titles, what we're going to do is we're going to say that the header equals true, meaning there is a header of titles. And here, this is the name of the file we are getting the data from. Okay. And now, the last thing we need to tell it is we need to tell it where the separations are. So we write sep equals, and that tells us what the separations are. And we're going to tell it that it is a separated using quotation. So this is how the data is separated. And you might be looking at these number signs and words after it and thinking to yourself, what is this? Well, what this is it's something called commenting. So it allows one to write what this line of code is, explaining what's going on here. But the compiler, when we run it, won't read it. It'll just ignore everything on that line after that sign. So if I go now here and I press Control Enter, I'm now going to run this line and we'll see, oh, it pulled some data and has 3 OBSs of 2 variables. And if we press data, you can see it opens the data frame and we've got our color, our number, and then it's got the 3 colors and it matches exactly what we had before. So our data is now stored as a data frame within our file. And you'll notice that even if I were to, so if I'm here and I run, so if I go to tools, if I go plots, go view, if I press this run button here, it'll run the frame. It still hasn't saved my script. So when we're compiling it and uploading the data and doing everything, the script's not being saved. It's just running our commands. And because we want to use this later, it's always good practice to just save the file every once in a while. Note that when you save the file, it does not run your script. It simply saves what you type. So now that we've learned how to upload the data, we're going to learn how to call some of the data. So if I just simply type data and press enter, it's going to print out, if we look down in the console, the entire data frame, the titles, the numbers, everything. Now, let's say instead, I didn't want the whole data frame. I just wanted the colors. If I put this $sign, it then tells me what I can pick. I can pick the colors or the number. And if I pick color, now if I do it, it just gives me the color, red, then blue, then green. Whereas if I want the number, I can type in number, pressing enter will autofill what's highlighted, and Control Enter, and I'm printing the number. So that's how we call the number and the